Take note that all papers are downloadable. You can also zoom in or out depending on your liking. The backlog starting 2016 will also be published soon. The Transactions NASFIL will be a key platform for the timely release of advisory documents of NASFIL as part of its advisory functions. Let's make a timely and relevant Transactions NASFIL. Collaborate with us by visiting transactions.nas.ph or email us at publications@nas.usp.gov.ph.
Of our house rules. Proper decorum is expected among all participants. Any act of disrespect and rudeness shall not be tolerated throughout the duration of the webinar. Kindly key in your questions for the panelists in the Q&A. These will be answered during the open forum.
Gandang umaga po sa lahat. On behalf of the National Academy of Science and Technology Philippines and the Microbiology Consortium of the Philippines, I am pleased to welcome you all to the last of the three-part series of the focus group discussions on microbes and climate change, focusing on human and animal health. I am academician Windel L. Rivera, Chair of the NAS Biological Sciences Division, also the Chair of the Microbiology Consortium of the Philippines, and I will be your moderator for today's focus group discussion. Let your friends know that you are attending this activity. Please use the official hashtags, #PilipiNast and #Microbes and Climate Change. A few reminders before we start. Kindly key in your questions in the Q&A box on Zoom. And for those streaming in the NAS PHL Facebook Live, you may type in your questions in the comment section. The speakers will answer your questions during the open forum. Now, to receive an e-certificate for attending this activity, participants are requested to fill out an evaluation form after the program. The link to the evaluation form will be announced later. At this point, let us hear from academician Eufemio T. Rasco Jr., Interim President of NAST Philippines, also the Chair of the NAST Agricultural Sciences Division, to give us the welcome remarks. Let us welcome academician Eufemio T. Rasco Jr.
Distinguished participants, ladies and gentlemen, my dear friends of science, technology, and innovation. Magandang umaga sa inyong lahat. On behalf of the National Academy of Science and Technology Philippines, I am pleased to welcome you all to the last of the three-part series of focus group discussions on microbes and climate change, this time focusing on human and animal health. Academician Asuncion Raimundo NAST focal person on microbiology education, together with the Biological Sciences Division Chair, Academician Wendell Rivera, Academician Virginia Cuevas, and corresponding member Francis de los Reyes III, initiated this series of focus group discussions on microbes and climate change. The first and second FGDs were held last November 19, 2022, and January 27, 2023, respectively. The first FGD involved discussions on the updates and overall perspective on microbes and climate change, and the network models for climate change mitigation and adaptation. The second FGD focused on the impact of climate change on plant microbe interactions, adaptation and mitigation measures in agriculture, the role of climate change in the conversion of waste, and marine environmental monitoring initiatives. For this session, the presentations will focus on confronting emerging infectious diseases and climate change and antibiotic resistance, the dynamics and impact of the climate crisis on infectious disease threats, and lastly, the impact of climate change on animal diseases. These FGDs aim to help targeted stakeholders become aware of the role of microbes in climate change and factor them into their research models and policies. I thank our resource persons, Dr. Francis C., Dr. Jason Burnham, Dr. John Mark Velasco, Dr. Adrian Ibanez, Dr. Bachel Gay Pallier, Dr. Leslie Michelle Dalmacio, Dr. Raymond Francis Sarmiento, and Dr. Lucille Villegas for accepting our invitation to share their time and expertise in this very important and timely activity. My sincere gratitude also to the organizing committee, headed by Academician Rivera, Academician Raimundo, Academician Cuevas, and corresponding member De Los Reyes III for spearheading this FGD. Let me extend the Academy's appreciation to all of you who have given your time to attend this activity. I look forward to the excellent presentations and fruitful discussions during the open forum. Thank you and a pleasant morning to everyone.
Thank you very much, Academician Rasco. Now, let us have a brief overview of this FGD. As mentioned earlier, this focus group discussion is the last of the three-part series on microbes and climate change organized by the NAST Biological Sciences Division and the Microbiology Consortium of the Philippines. Today, we will get a clear picture on the role of microbes and climate change in human and animal health. As we are aware, climate change affects the occurrence and spread of infectious diseases. It can increase the risk by altering host and pathogen acclimation. It is also predicted to increase the rate of antibiotic resistance of human and animal pathogens. Potential underlying mechanisms include elevated temperatures, facilitating pathogen growth rates, promoting environmental persistence and transmission. Population growth, which amplifies climate change, is also an important factor in transmission of infectious diseases. Vector-borne, foodborne, airborne, waterborne, and other environmental pathogens may be particularly susceptible to the effects of climate change. Ignorance of the role of, effects on, and feedback response of microbes to climate change can lead to our own peril. An immediate, sustained, and concerted effort is required to explicitly include microorganisms in research, technology development, and policy and management decisions on climate change. With that, I am honored to introduce to you our esteemed keynote speakers. We are very thankful that they accepted our invitation to speak in today's FGD. Our first keynote speaker is Dr. Francisco S.C., and he will be discussing confronting emerging infectious diseases and climate change from local to global. Dr. C is a professor and chair of the Department of Environmental and Occupational Health at the University of Nevada, Las Vegas School of Public Health since June 2016. He is the principal investigator of the Mountain West Clinical and Translational Research Infrastructure Network, funded by the National Institutes of Health, the National Institute of General Medical Sciences. He has been the editor of AIDS Education and Prevention, an interdisciplinary journal since 1988. Dr. C worked at NIH for 12 years. He was the director of extramural activities at the National Institute on Minority Health and Health Disparities. He was president of the Asian Pacific American Organization at NIH. When he retired from NIH in May 2016, the Federal Asian and Pacific American Council created the annual Francisco C. Excellence in Mentorship Award. At the Centers for Disease Control and Prevention, or CDC, Dr. C was a senior health scientist in the Division of HIV/AIDS Prevention for 4 years. He was a member of the CDC SARS Outbreak Investigation Team in 2003. He led the CDC SARS Outreach Team in Asian communities. He was an associate professor of epidemiology at the University of South Carolina School of Public Health for 15 years. Dr. C earned his Doctor of Public Health degree in Immunology and Infectious Diseases in 1984 from the Johns Hopkins Bloomberg School of Public Health, and his Master of Science in Tropical Public Health in 1981 from the Harvard T.F. Chan School of Public Health. He obtained his MD degree in 1975 and BS Pre-Med in 1970 from the University of the Philippines. Our second keynote speaker will discuss climate change and antibiotic resistance, what is and what may be. Dr. Jason P. Burnham is an assistant professor at the Division of Infectious Diseases, Washington University School of Medicine, St. Louis, Missouri, in the USA. Dr. Burnham has published extensively on both antibiotic resistance and climate change. On the subject of climate change, he has identified energy utilization, primarily via hospital heating, ventilation, and air conditioning, as the major driver of carbon footprint in intensive care units. He has shown that most operating rooms are not utilizing off-hours energy setbacks to reduce their carbon footprints. And he has contributed to the Green Print, an agenda for advancing environmental sustainability in healthcare. On the subject of antibiotic resistance, he has numerous papers on clinical outcomes, such as mortality and readmissions for patients with various antibiotic-resistant infections, including Acinetobacter, Staphylococcus aureus, Enterococcus, Pseudomonas aeruginosa, and Enterobacterales, among others. In addition, he has published on the intersection of climate change and antibiotic resistance, which gives him a unique perspective to comment on the future of antibiotic resistance in a progressively warming world. So to deliver the presentation on confronting emerging infectious diseases and climate change from local to global, ladies and gentlemen, let us all welcome Dr. Francisco S.C.
Thank you, Wendell. Let me upload my screen. Oh, God. Let me see. Can you see my screen? Wendell, can you see my screen now?
Yes, Dr. C, but we can also see your notes.
Oops. Well, I just start. So these are the 6 learning objectives. I want to discuss the convergence model of human and microbe interactions, followed by a discussion on factors responsible for emergence of infectious diseases. I'll also discuss the neglected tropical diseases and the WHO roadmap for the NTDs, and a discussion on how climate change affects transmission of diseases as well as human health, and then what kind of intervention we can do at a global level. And I'll end by talking about One Health. So this is a convergence model. As you can see here, there's a lot of factors that come into play that cause the microbes and humans to interact and cause a disease transmission. Climate change is just one of the factors. There's a lot of other factors involved, like for the humans, you have the genetic and biological factors, and then the social and political economic factors are very important too. And of course, the physical environment and ecological factors play a role. So all of these factors play a role in causing the convergence and the disease to the microbe and humans to interact. So emerging disease can be defined as infections that have newly appeared in the population, or it could be an existing disease that have increased rapidly, not only in incidence, but also in geographic range. It could be an outbreak of a previously unknown disease, or an outbreak of a known disease that's increasing in incidence, or persistence of disease that cannot be controlled. So all of this could be defined as emerging infectious diseases. So this is a slide showing you that there's a lot of pandemic that have occurred since long time ago, from the plague up to the present time. We're not in the midst of COVID-19, but before COVID-19, remember in the early 80s we have HIV/AIDS, and 2003 we have SARS, we have H1N1, swine flu, chikungunya, Zika, and now in the midst of COVID-19. So these are just some examples of emerging diseases here that I mentioned earlier, including some of the re-emerging diseases like malaria, TB, cholera, pertussis, influenza, pneumococcal, and gonorrhea. So the question is, what are the factors that cause them to emerge? So in 1992, the Institute of Medicine convened an expert panel, and they came up with 6 factors. The first factor is microbial adaptation and change. And that's the only factors that affect the microbes. If you look at the other factors, these are due to our human activities like economic development and land use, human demographics and human behavior, including sexual behavior, international travel and commerce. As you can see, population movement as part of that, technology and industry. So you can see improvement in technology, and all of these things could lead to increased travel and breakdown of public health measures. If there's a war going on, or a breakdown in some of the public health measures could stop and lead to emergence of diseases. This was in 1992. In 2003, the Institute of Medicine convened again another expert panel to look at what are diseases, what are the other factors. So in addition to the 6 factors identified in 1992, there are additional 7 factors that they identified, including human susceptibility to infection, climate and weather. This is the topic for today. Changing ecosystem, poverty, increased social inequality, health inequity, war and famine. You're seeing now what's happening to Ukraine, population movement, lack of political power of will of different government, and the intent to harm, by terrorism, where they use biological agents as a biological weapon. So what are the neglected tropical diseases? There are about 20 diseases that are very prevalent in tropical areas that affect 1 billion people. And they include viruses, bacteria, a lot of parasites, fungi, and toxins. And most of them have very complex epidemiological life cycle, and they involve environmental conditions. A lot of them are vector-borne. A lot of them have animal reservoir hosts. And so they need to, for prevention, need to look at both intervention for the vectors as well as for the animal reservoir host. So of the 20, I listed the 10 that are very common. And as you can see, most of them are vector-borne disease like Chagas disease, the American trypanosomiasis caused by triatomic kissing bugs, dengue and chikungunya caused by Aedes mosquitoes, dracunculiasis caused by drinking coffee pods with the organism, the Dracunculus medinensis, human African trypanosomiasis transmitted by Cheche fly, and then leishmaniasis transmitted by sandflies of pleviotomin species, Hansen's disease, which is leprosy, which is due to prolonged contact with someone with with untreated leprosy. It takes months before you get infected with leprosy. Filariasis caused by Aedes mosquitoes, onchocerciasis transmitted by black flies, and schistosomiasis transmitted by snail, and soil-transmitted helminthiasis like ascaris, tracheus, and hookworm. I've highlighted the 5 diseases in yellow, and these are the 5 diseases that can be controlled, and they can even be eliminated by mass drug administration or very safe, effective medication, and also effective intervention for the mosquito or for the snail. So WHO had a new roadmap for the NTDs until 2030. And the goal is that by 2030, 90%, there'll be 90% reduction in people requiring intervention against these NTDs, 75% reduction in disability life years, 100 countries would have eliminated at least one neglected disease, and the goal is to eradicate 2 diseases by 2030. These 2 diseases are dracunculiasis and Yaws. Yaws is a non-venereal Treponema pallidum pertenue, and there are a few cases right now for both dracunculus and Yaws. So the goal is that by year 2030, hopefully they'll be eradicated and join smallpox as a disease that has been eradicated. So this is a picture to show you how Aedes aegypti look like, and that's a vector for dengue, Zika, chikungunya, and yellow fever. For the people and entomologists in the audience, you can see that vectors play a very important role in this infection. This is how a triatom look like. It's a kissing bug, the vector of Chagas disease or American trypanosomiasis. The feces of the bug is the one that caused the infection, and they like to kiss the humans around the eyes or the lips, and usually this occurs in the evening. And now going to our topic today, which is about climate change and health. So we know all about these different diseases and what's the connection, how come they make you sick. So you can see here that the climate change affect health, not only in terms of vector-borne disease, but you can see, well, let's start with the 12 o'clock here. You can see that it affects, because of the way the wind blows, you can see it can cause asthma and cardiovascular disease because of the air pollution. The vector-borne increases in number of vectors can cause malaria, dengue, and other vector-borne diseases. And also the pollen can cause a lot of allergy, respiratory diseases. And then the water contamination during flood and hurricanes, you can see increasing cholera, cryptoperdiosis, and leptospirosis. And environmental refugees, because of war and famine, you can see diseases increases. Also, the mental health could be could affect the people in terms of anxiety, increase in despair, depression, and post-traumatic stress. And water can be contaminated, and there could be short supply with food, increase in food insecurity causing malnutrition. The heat can also cause heat stress, cardiovascular failure, and then severe weather can cause a lot of fatalities and injuries. And this slide shows you, the extent of diseases, not only viruses, bacteria, fungi, and protozoa, caused by all these changes in global warming, precipitation, flood, even drought and storms, and changes in the like fires or heat waves and etc. And there are about 17 diseases that we have vaccines available for polio, for mumps, pertussis, diphtheria, Japanese encephalitis, pneumonia, cholera, and COVID-19, right, and hepatitis. So how does climate affect pathogen ecology? There's a lot of variables involved, like temperature change, precipitation, humidity, wind, and other variables. And the scale of response could be temporal, daily, monthly, or annual, and it could be local or regional. And you could see that this could affect the increase in number of pathogen, increase in the vector range, and it could be seasonal. And these are all depicted in this picture. And these slides are from NASA. And you can see that the effect on the pathogen ecology could be creation or destruction of the habitats, contamination of the water, change in life cycle, cycles of transmission, introduction of new pathogen, and then this change in the range of species of the, and this may take some time, weekly, monthly, or annual, and it can also affect the vector proliferation, pathogen development. There's a lead time involved with this in terms of reservoir hosts and other colonization of the pathogen and evolution of the organism. So what can we do to control this? What kind of interventions can we think of? These are about 6 intervention strategies for climate change and disease intervention. And I'll summarize in the slides here that we need a transdisciplinary approach. So you cannot just do it alone. You need to work with others together. Collaboration is very important. And I think because of the health sector is one of the play a key role in terms of emissions. So there should be mitigation in the emission in the environment. We need to have increased funding for research. I just saw today in the NIH guide that there's the Fogarty International Center have funding in the area of climate change and infectious diseases. So we need more funding from our government to do this. Also, we need to have more predictive modeling system, early warning system, and integrate them into forecasting, and then this will help our decision and policy makers. We need to enhance the environmental information that we have, and also improve our disease surveillance. And lastly, we need to build human capacity in data management, integrate surveillance and leadership. We need to create career paths for people who are interested to pursue a career in climate and health research area. So I want to end my talk with the concept of One Health, wherein we want to connect human, animal, and environment. Since our talk today involved all this topic, I think this concept is very important. One Health is the idea that the health of people is connected to the health of animals and our shared environment. So when we protect one, we help protect all. So why is it important? Because as Earth population grows, our connection with animals and environment changes. As you can see, people are living closer together now, and we're getting closer to our environment too. So there are changes in climate, is affected by land use. There are more travel, more trade, as we mentioned in the emergence factors, and animals are also very important. So all of these factors make it easier for disease to be spread. So One Health approach tackles shared health threats by looking at all angles from human, animal, plant, and environment. I think the rest of the speakers this morning will talk about it. And so One Health is just an approach, right? But it's very important to collaborate and then involve different sectors and transdisciplinary. And we need to work not only at local level, in our local region in the Philippines or in the States, but we need to work nationally and globally together. And our goal is to achieve optimal health, interconnection between people, animals, plants, and our environment. And vector-borne disease is just one area, priority area for the One Health. But as you can see, environmental health is very important too, and food safety, and zoonotic diseases, which will be discussed later, and antimicrobial resistance will be discussed by the next speaker. So I want to end with this slide showing you that One Health involved everyone, not just medical doctors, scientists, veterinarian, healthcare workers, epidemiologists, but also everyday people, the citizen, all the community members should be involved, working together. And I want to end with this slide that we're all in this together. Each one teach one. We must all work together to prevent, control these infectious diseases, promote One Health, and promote Bayanihan health. Thank you.
Well, thank you very much, Dr. C, for that very informative talk. Clearly, we have seen there, and it was emphasized by Dr. C, that intervention should be a transdisciplinary approach, and one approach is, of course, the One Health approach. Okay, so let's move on to the next talk to discuss climate change and antibiotic resistance. What is and what may be? We would like to call now Dr. Jason P. Burnham.
Thank you. Thank you for having me. All right, here we go. I'll share my screen. All right. Well, thank you so much for having me. It's an honor to be here speaking to all of you. So I'm going to, and that was a great talk, Dr. C, and I can already tell some of the themes are going to go through all of the talks today. So I'm going to start off with a little bit of background. There we go. So Dr. C has mentioned some of this already, but climate change is intimately linked with human morbidity and mortality. And because of the way that it arises, it's a social justice issue. The wealthiest countries and corporations overwhelmingly contribute to the greenhouse gas emissions and pollution that are responsible for climate change. But those effects are not uniformly felt, and low and middle income countries are often bearing the brunt of climate change related disasters. And so it's a social justice issue in that way. And when we think about the contributors to climate change, you know, as healthcare providers, healthcare itself has a pretty large carbon footprint. And so in the spaces that we can make a difference within our own healthcare systems, we have to, you know, do what we can so we're not harming our patients indirectly by making the climate worse. So shifting to more specifically around climate and antibiotic resistance, why is this important? Because as the climate changes and antibiotic resistance increases, you know, modern healthcare, as we think of it, modern medicine is really impossible if you don't have effective antibiotics. Surgeries, and this is not just talking about trauma surgeries, this is any kind of surgeries, elective procedures, etc. The first thing that happens before a surgery is you administer preoperative antibiotics, 30 minutes to an hour before the first cut. The antibiotics go into the patient. And if bacteria are resistant to those antibiotics, then they're not doing their job, and the patients are at high risk of getting a surgical site infection. So, if you can't do any surgeries, people's health outcomes are going to be a lot worse. And that affects not only necessary procedures, but, sort of elective procedures. And as we know, elective procedures eventually become urgent and emergent procedures. So it affects the whole cascade if you don't have effective antibiotics to prevent surgical site infections before they happen. And then when they do happen, because 100% of surgeries, there's bacteria in the wound. It's just that we have wound care and antibiotics to prevent those bacteria that get in there from causing harm. So not just surgery, but a lot of aspects of modern medicine are not really possible without effective antibiotics. Cancer treatment, organ and bone marrow transplantation, other medications for autoimmune conditions, anything that lowers the immune response. In some patients, especially those on high doses of chemo or undergoing transplant, bacterial infections are almost guaranteed. So if you have for example, a bone marrow transplant patient who gets their bone marrow completely wiped out by cancer chemotherapy, they're going to get a bacterial infection. And if that is resistant to antibiotics, then they have a high risk of dying from that. And in an instance such as that, we may actually be shortening their lives because we've wiped out their bone marrow and now they have an infection. So these sorts of things aren't possible. And then just sort of routine infections, or quote unquote routine, treating ear infections in kids, diarrheal illnesses, pneumonias, skin and soft tissue infections, cellulitis. If you don't have effective antibiotics for those, some people may get over them, but you may get pretty sick first, and there will be people who die if you don't have effective antibiotics. So it's a very important issue. This slide here, I don't intend for everyone watching to absorb all of the branches of the diagram, but this is taken from a United Nations Environment Program report that they just put out, Bracing for Superbugs, which is an excellent report, and I encourage everyone to take a look at that. But as Dr. C mentioned, we're all in this together. Everything is connected here: the environment, wildlife, the air, the water, the soil. Everything is connected, and anything that happens in one part of this diagram is going to be felt by the rest of the players on the diagram. So we're all in it together. All right. So the outline for the talk, it's sort of a mechanistic talk in terms of how is climate change exactly resulting in antibiotic resistance. So we're going to talk about heat, disasters and/or extreme weather events, pollution, waterborne infections and sanitation, and what I call downstream or indirect antibiotic resistance, which is related to climate change, but it may take more steps, but the connections are there. So we'll start off with heat and antibiotic resistance. You may have seen a diagram like this in a chemistry or a biology or biochemistry or any of these science courses, and maybe it was a long time ago, but this is a diagram about activation energy. So when you have a catalyst, reactions occur more quickly. And how does that relate to bacteria and antibiotic resistance? Well, heat is a catalyst for bacterial gene transfer. And while not all genes that are transferred between bacteria are antibiotic resistance genes or antibiotic resistance cassettes, I'll sort of refer to those interchangeably throughout the talk. That is something that gets transferred between bacteria, and that's a defense mechanism. Bacteria make antibiotics to fight off other bacteria, and so they're going to be exchanging this material at higher rates the warmer it is. In addition, to there being more gene transfer, the bacterial growth rates are accelerated by heat. Now, of course, at a certain temperature, nothing can live, but we're talking about survivable temperatures for humans. So within that growth range, heat is going to increase bacterial growth rates. So more bacteria, more gene transfer, more antibiotic resistance. And this slide represents many, many studies that have come out regarding heat and infections. So heat has been shown to increase the rates of gram-negative bacteremia, infections due to antibiotic-resistant Acinetobacter, bacteremias in hospitalized patients, and this is not just gram-negatives, but any bacteremia, cellulitis in skin and soft tissue infections, urinary tract infections requiring hospital admission, surgical site infections. Then this has been demonstrated for many different types of surgeries. Knee replacements, hip replacements, colon surgeries, urologic procedures, gynecologic procedures, essentially all of them. So although that's just one line here, there's studies showing that for basically many different types of surgeries. And then Legionnaire's disease or legionellosis is increased by heat. And for antibiotic resistance, more specifically, there have been studies to show that heat increases the number of infections due to antibiotic-resistant E. coli, Klebsiella pneumoniae, Staphylococcus aureus, and Acinetobacter. Now, these are some of the most common organisms that cause infections that come to clinical attention. E. coli and Klebsiella are some of the most common Enterobacterales, and Staph aureus is obviously one of the most common gram-positive infections. I have no reason to believe that if large enough studies were done, that this would not be true for other bacterial pathogens. As you can imagine, in order to get a signal for a difference based on heat in terms of the rates of resistant infections, you have to have a certain sample size and you have to have the funding to do it. As Dr. C alluded to, we need more funding to study these sorts of things. But I have no reason to believe, and there's really, mechanistically, it makes sense that any bacteria will have more infections with increasing heat. So I suspect it's just a lack of funding to do these studies and/or small numbers. There's probably not enough cases of what's a good one? Roseomonas or something that doesn't really cause a lot of human infections to say, oh, okay, well, it increases with heat. We just can't detect a signal. So, and then a big one, Salmonella. Heat has been shown to increase poultry intestinal colonization by Salmonella. And also salmonellosis is more common in humans at higher temperatures. So this is a very important global pathogen, and heat could make it worse. We're going to shift topics a little bit. This is sort of the next bullet on the outline. We're going to talk a little bit about weather events and antibiotic resistance. And again, Dr. C alluded to this some, but really how these two are related is it's about the movement of people and vectors. So a little bit of sort of the physiology of the planet, as it were. Warming climate, what happens is as the atmosphere warms, it has a greater capacity to hold water, which leads to more extreme weather events. Droughts may be a surprise here because you wouldn't normally think of that as more water equals more drought, but it's not a uniform distribution of how these weather patterns go. So some place may get a lot more rain, and nearby there may be a lot longer and more severe droughts. So it can increase. The warming climate causes more floods, hurricanes, typhoons, and with these large extreme weather events, you get displacement of people, climate refugees, and this, as these extreme weather events become more and more intense and severe, this is going to continue to be a bigger problem. Anytime there's people fleeing from their homes, their cities, wherever. There's going to be overcrowding, and population density is a strong risk factor for pathogen transmission. Just think, if you got COVID-19 and you live out in the country and there's nobody around you, the R naught, or the number of people that you're going to spread it to, is 0 because nobody is there. But if there was just a giant flood and your whole town is packed into some small building, the R naught could be 100 if there's 100 of you in this small, tiny space. And obviously that's a respiratory virus, and that's not totally the same method of transmission as bacterial infections. You can think of tuberculosis as another one that depends on population density, and even some bacterial infections. MRSA colonization is more common in crowded settings. So putting more people into the same small space is going to increase risks. And with these weather events, sanitation systems may break down or totally obliterate them, or there may have been none present where these people are displaced to. Sewage is a known reservoir for antibiotic resistance genes, and so spreading sewage is just a setup for infections. In addition to human waste, the overflowing of farming and livestock fields is going to increase the rates of contamination. Touching a little bit on plants and how they play a role, there are studies that show as the climate warms, plants need more fertilizer in order to achieve the same crop yields. And these fertilizers are nitrogen based, and there's many studies showing that when you have nitrogen fertilizers in the soil, and as the concentration increases, you increase the rates of antibiotic resistance. So tying that back to extreme weather events, you have these fields polluted with nitrogen fertilizers. The flood comes through, the hurricane, typhoon, whatever it is, washes all these out and is mixing these antibiotic resistance genes into water systems and water tables that are exposed to people and animals, and just a setup for further development and spread of antibiotic resistance. So that ties in nicely to pollution and antibiotic resistance. So bacteria are not like us. If humans, if we had a DNA polymerase that put in a lot of errors into our DNA, we would be in trouble. We would have way high rates of cancer. There would be troubles with our germlines, there'd be trouble reproducing. But bacteria are different. They sort of operate on a numbers game. If they have DNA polymerases that are error prone, and this is evolutionarily advantageous for them, because if there's, for example, an antibiotic floating around and they put in one error in their base pairs that results in a change in their topoisomerase that allows them to be resistant to that antibiotic, then that clone is going to survive and proliferate, and the old clone is going to be killed. And this process, this sort of stress-induced process of introducing DNA errors, something called mutagenesis, and that allows new mutations that permit survival. And there's all sorts of environmental stressors that bacteria respond to in this way. Antibiotics are one of them, which could be human-made, either from sewage or people dumping antibiotics into the trash or down into the sewage system after they're done with them. This could be pharmaceutical waste. This could be hospital wastewater systems, also, or it could be from other bacteria. So antibiotics can be present in the environment in many different ways. Other things that can induce mutagenesis include chemicals, radiation, pollutants. Oops, excuse me, went too quickly there. Pollutants like nitrogen fertilizers. And this picture here is an algal bloom in the Gulf of Mexico, which has been worsened over time by nitrogen fertilizer runoff from the Mississippi River. Other pollutants that can stress bacteria are heavy metals and pharmaceuticals. So pollution, as far as heavy metals go, manufacturing and industrial practices often produce heavy metals as byproducts, and whether those are dealt with appropriately or not, that there are different regulations in different places, but regardless of how well they're handled, if an extreme weather event comes through and knocks out a plant, all those heavy metals could end up in the water systems, where there have been studies to show that higher concentrations of heavy metals in the soil induces antibiotic resistance in soil bacteria. And while humans don't get a lot of soil bacteria-based infections, those soil bacteria share those genes. They share them with human pathogens. They share them with all the contacts that we have. Going back to that sort of we're all interconnected diagram from early on. Another source of pollution that contributes to antibiotic resistance that on the surface you might think, well, that's kind of strange. But if we think about the patients that we see in hospitals, plastics are a source, an opportunity for increased bacterial gene exchange, which gives more opportunities for the exchange of antibiotic resistance cassettes. So if we think about the patients that we see in hospitals, for example, those with implanted devices of various sorts, it could be a catheter, into their bloodstream, or a catheter in their bladder, breathing tube, anything that's plastic. It's a setup for biofilm formation. And so basically what's happening is these microplastics are just where biofilms are forming. The bacteria can exchange these genes, and microplastics are everywhere, even smaller ones than the ones shown in this picture. Studies have recently come out how they're in the air, they're in rain droplets, they blow on the winds. They've even been detected in human placenta. We certainly all ingest them in our food. They've been found at the bottom of the Mariana Trench, in the deepest parts of the ocean. They're everywhere. And so these are just nidus's for antibiotic resistance transfers and development. This is another diagram from the United Nations Environment Program report. And I really do, it's an excellent read. So I definitely encourage everyone to check it out. This is another form of pollution that they talk about, and that is pollution from antimicrobials. This graph is just demonstrating that it's not a uniform distribution of this antimicrobial pollution. This can come from many different sources: hospitals, companies, pharmaceuticals, etc. And all of these polluted antimicrobials are contributing to antibiotic resistance. So just to be aware that that is also another source. This is another nice diagram from that figure showing the interconnectedness of us all. And as it relates to pollution and extreme weather events, just circled here, the large fluxes of resistant microbes and selective agents during storm events, going back to what I talked about, floods and waters coming through the groundwater, you see the pollutants from above, the people, the cars, etc. Then the landfills, the water shared with recreational use, humans, animals, and just again, we're all connected, and anything that happens in one spot is going to affect all of us. This ties into waterborne infections and sanitation. So I talked a little bit about droughts earlier, but one thing to be aware of is that when there's a drought, we think of mosquitoes as replicating and reproducing and withstanding water, but during a drought, mosquito predators die off. And so there's actually sort of a population boon for mosquitoes during droughts at times. And when there's a drought, there's water scarcity, which can reduce sanitation. In addition, more people are sharing this smaller water sources, which is a setup for infection outbreaks. In addition, water scarcity leads to decreases in crop yields. And when you're eating less, your nutrition is worse. And unfortunately, we know that when you have poor nutrition, protein, calorie malnutrition, just from a lack of access to food, you're at an increased risk of acquiring infections. And this is particularly true at the extremes of age, the very young and the very old. And when you're malnourished and you have a severe infection, there's a higher chance you're going to be sicker, that you're going to have to go to the hospital, and that you're going to die. And when you couple that with antibiotic resistance on top of that, you know, if you get a diarrheal bacterial pathogen that puts you in the hospital and there's no treatment options for it, that's just a setup for death and heartbreak. Moving on to downstream or indirect antibiotic resistance. This is sort of a grab bag of different topics, but Dr. C touched on this a little bit, the movement and expansion of vector habitat. So just sort of a clinical pearl that I see in the United States is that that's a good way to demonstrate this. People who live in malaria endemic countries that come to the U.S., they throughout their youth, they're constantly exposed to malaria, so they develop this sort of immunity to it. Then they come and live in the United States, and after a while they say, okay, I'm going to go home and visit my family. But they don't take any malaria prophylaxis because they're so used to living there and they don't worry about it. And then they come back to the U.S. after their trip and they have really bad malaria because they're no longer immune to it. And as the climate changes, not only could we see climate refugees moving into places where the mosquitoes are, the mosquitoes' range may change and expose entirely new populations that are not usually exposed to malaria. And so you're exposing naive populations. And when you expose naive populations to something they don't have any immunity to, they're more likely to have a severe infection, they're more likely to die, and they're more likely to be hospitalized. So as we saw during the COVID-19 pandemic, when people were severely ill with COVID-19, they were in the hospital for a long time, and they developed hospital-acquired infections. These things they happen. We try our best to prevent them, but when you're on a breathing machine for a month, you know, eventually all that you're bypassing your body's natural immune systems to keep those pathogens out. And hospitals are a sink for antibiotic resistant pathogens. So naive populations being exposed to new diseases, more hospitalizations, more antibiotic resistant hospital-acquired infections. And this is particularly important because some studies estimate that over 500 million people more than already are at present are going to be at risk for vector-borne illness by 2050. I've touched on this a little bit, talking about malaria and vectors, but basically as malaria's range expands, you're going to have anti-malarial resistance spread just because of more opportunities, you're going to have harder to treat infections and more deaths. I mentioned tuberculosis a little bit earlier about how population density and crowding can increase transmission. And again, going back to the extreme weather events, when you have people all sort of crammed together because they've lost their homes, their livelihoods, there's a higher risk of transmission of tuberculosis. And then there's actually some studies that show in areas of drought, there are higher rates of antibiotic resistant TB. And as droughts get more severe, this may become more of a problem. And if anyone on the call has treated antibiotic resistant TB, that is a real challenge, and the outcomes are not nearly as good. Another aspect that I touched on very early on in the talk was just about the general morbidity and mortality of climate change. So particulate counts have been strongly correlated with pulmonary and cardiovascular morbidity. The more particulates, the more hospitalizations, more heart attacks, more pneumonias that come along with that. And so you're going to have sicker populations that are having to be in the hospital for longer. Again, going back to this idea that the more you're in the hospital, the more risk days you have for getting an antibiotic resistant infection. And as we damage our lungs, you get these sort of dead areas of the lungs that are setups for biofilm formation for resistant bacteria. So nothing good on that front. And I think I'm getting close to my 30 minutes, so sorry if I'm speeding up a little bit. Another aspect of downstream antibiotic resistance I touched on a little bit, livestock and crop yields seem to decline as the climate warms. And historically, antibiotics have been shown to increase crop and livestock yields. The mechanisms are not totally clear in some instances, but the thought is that it reduces pathogen burden. But as the yields go down with climate change, even though there's legislation in place to try to stem their use, people, I mean, that's their livelihood, right? That's how they're living. That's how they're making their money. They're providing for their families. They may be at increased pressure to use these antibiotics to maintain their livelihoods and feed their families. So that, you know, the pure tonnage of antibiotics that are used in livestock and crops is huge compared to how much humans use. So if that goes up, that's another source of spread. I think this is one of my last slides. Again, this is from the UN Environment Program. And this is just showing that even despite legislation, fungicide and bactericide use in agriculture has increased. And this only goes back to 1990. And this is basically, you know, a 50% increase, even though we know it can cause a lot of downstream resistance. So yeah, this is I think this is my last slide, but hopefully, you know, I've touched on the things that sort of are the mechanisms for antibiotic resistance development. Heat causes more bacterial growth, more antibiotic resistance transfer. Disasters and extreme weather events are spreading these things in the population. Pollution is getting spread by extreme weather events, and the things that are in the pollutants are inducing antibiotic resistance in the soil bacteria that exchange with human pathogens. Waterborne infections, again, extreme weather events, and sort of niduses for antibiotic resistance development. And then sort of what I call the grab bag, the various different downstream resistance patterns that we see as a result of climate change. So I know that questions will come up later, but thank you so much. And this was a really good forum, and I'm so glad that I was able to give this talk. Thank you.
Thank you very much, Dr. Burnham, for that very insightful presentation. Of course, we've learned a lot from your talk. We've seen clearly the link between antibiotic resistance and climate change, also the factors that you've mentioned. And I find it really interesting that microplastics can also provide opportunities for antibiotic resistance, specifically gene transfer. Okay, so I will now introduce the rest of our invited resource speakers. Well, our next speaker to discuss the dynamics and impact of the climate crisis on infectious disease threats is Dr. John Mark S. Velasco. Currently, Dr. Velasco is a research faculty under the Institute of Molecular Biology and Biotechnology of the National Institutes of Health, and also a clinical associate professor at the Department of Clinical Epidemiology of the University of the Philippines College of Medicine. Dr. Velasco earned his Bachelor of Science in Biology, Master of Public Health, and Doctor of Medicine degrees from the University of the Philippines. His research interests encompass various disciplines, including virology, emerging and re-emerging infections, emerging antibiotic resistance of multi-drug organisms, clinical and molecular epidemiology, electronic disease surveillance, infectious disease modeling, and clinical trials. He was recognized by the National Academy of Science and Technology as one of the outstanding young scientists in the field of public health, commended by the Philippine Senate and Philippine Congress as one of the outstanding young men of the Philippines in the field of medical science and public health, and also a distinguished alumnus awardee of the University of the Philippines for medical science research. Our next speaker will discuss, is climate change impacting animal diseases? Dr. Adrian P. Ibanez is the director of the Institute for Molecular Genetics, Parasitology, and Vector-Borne Diseases, and a professor at the College of Veterinary Medicine of Cebu Technological University, Cebu City, Philippines. He obtained his PhD in Veterinary Sciences, Internal Medicine from the United Graduate School of Veterinary Sciences of Gifu University and Obihiro University of Agriculture and Veterinary Medicine in Japan. Dr. Ibanez was among the top 100 Asian scientists for 2022 and one of the achievement awardees of the National Research Council of the Philippines in 2019. Also, one of the outstanding young scientists in 2020 given by the National Academy of Science and Technology. He also received the 2021 Leeds Agri Award for Agricultural Research from the Philippine Association for the Advancement of Science and Technology for advancing animal parasitology and the study of vector-borne diseases in the Philippines. He is actively involved in multidisciplinary research, but is greatly interested in small animal medicine, parasitology, and tick-borne disease research. And our last speaker, obviously not the least, will discuss climate change and the emergence of zoonotic diseases. Dr. Vachel Gay V. Pallier is a professor and UP Scientist 3 of the Institute of Biological Sciences at the University of the Philippines, Los Baños. Her research interest is parasitology, focusing on the role of parasites in various ecosystems and their impact on public health. She has authored several scientific articles, book chapters, and laboratory manuals in parasitology. Dr. Pallier is currently the director of the Institute of Biological Sciences at UPLB. She obtained her doctoral degree from the Graduate School of Health Sciences at Kobe University in Japan. Dr. Pallier is also active in teaching, mentoring, research, and public service, but her passion is to do science to help improve the lives of the Filipino people. Dr. Pallier believes parasitology is a field needing more attention in developing tropical countries where parasites are widespread. Her research focus is on zoonotic parasites and the application of One Health in the control of zoonotic and foodborne neglected parasitic diseases. She is currently the Vice President of the Philippine Society of Parasitology, a regular member of the National Research Council of the Philippines, the Philippine American Academy of Science and Engineering, or PAASE, the Philippine Association for the Advancement of Science and Technology, the World Advancement of Science and Technology, and the American Society for Tropical Medicine and Hygiene. So truly, we have an excellent set of our research speakers this morning. So to deliver the presentation on dynamics and impact of the climate crisis on infectious disease threats, let us all welcome Dr. John Mark S. Velasco.
Good day, everyone. Today, we'll be talking to you about the impact of climate change on infectious diseases. As we can see in this slide, in just 150 years, scientists have observed a rise in global sea levels, carbon dioxide levels exceeding 400 parts per million, and a more than 1.2 degrees Celsius increase in global temperature. In the past 50 years, we've also seen a significant rise in global air travel, urbanization, and exploding population levels. We've also seen a parallel rise in the prevalence of existing diseases, as well as an increase in the number of emerging and re-emerging disease outbreaks and pandemics from novel pathogens. All of these developments are having a significant impact, especially on developing countries and their economies, with the Southeast Asian region forecasted to suffer the most losses, with a predicted 11% decline in GDP by the end of this century. Human health is also predicted to be impacted with a significant increase in the number of disability-adjusted life years attributable to climate change. Multiple indices rank the Philippines as one of the countries most affected by extreme climate events and experiences highly destructive typhoons such as Typhoon Haiyan. In the aftermath of typhoons, damages to the infrastructure, stagnant pools of water create environmental conditions favorable towards the rapid reproduction, growth, and spread of waterborne diseases such as cholera and leptospirosis, as well as vectors such as mosquitoes, which can carry many diseases. So this slide illustrates climate change impacts such as rising temperature, extreme weather, rising sea levels, and increasing carbon dioxide levels, and their effect on exposures and subsequent health outcomes resulting from these exposures. Particularly important are changes in vector ecology and its impact on arthropod-borne diseases such as dengue, chikungunya, Japanese encephalitis, malaria, and Zika virus. Vector-borne diseases have been directly correlated with changes in climate due to the change in environmental conditions, which may be biologically conducive and confer to the specific vector increased survival rates and expanded geographical range to spread and transmit diseases. Here, we can see the number of states in the US which have reported dengue cases in 2022. Though most of these cases are traveler-related, there exists local transmission and dengue outbreaks which occur in some states, such as Florida, where the temperature is more conducive for the Aedes mosquito vector to thrive. Another case in point is dengue. This is a vector-borne disease transmitted by the mosquito Aedes. It has been observed that abnormally high or low temperatures may reduce mosquito longevity and reproduction due to its effects on the mosquito's extrinsic incubation period. So this illustration shows a mathematical modeling study I did with Johns Hopkins Applied Physics Lab. And this shows the strong seasonality of dengue in the Philippines, when dengue usually starting to peak around June each year, which corresponds to the rainy season. Changes in climate can also impact respiratory viruses. So low related humidity and high population density was found to influence the spread of the pandemic H1N1 influenza virus back in 2009. More recently, many studies have shown the similarity of influenza and COVID-19 transmission, particularly during winter. There is also strong data supporting that COVID-19 will eventually become a seasonal infection, with the climate extremes promoting selection of more successful strains. Another dengue modeling study which we participated in, together with 8 countries in Southeast Asia, showed the synchrony in dengue incidence, which coincided with elevated temperatures throughout the regions, especially 1997 to 1998. This was the year with the strongest El Niño episode of the century. In particular, multi-annual dengue cycles occurring 2 to 5 years were highly coherent with the Oceanic Niño Index, or the El Niño phenomenon, which brings about the unusual warming of surface waters in the eastern tropical Pacific Ocean. Synchrony of these multi-annual cycles was found to be significantly associated with increase in temperature. In the same study, we found that localized traveling waves of dengue in the Philippines, Laos, and Thailand were highly dependent on temperature, with a 1.5 degrees Celsius increase in temperature significantly associated among provinces with outgoing dengue waves. Sustained high temperatures were found to be a powerful mechanism which forces synchronized spread of major dengue epidemics in Southeast Asia. So this is another study which we did in collaboration with Inha University of South Korea. We used the nonlinear autoregressive exogenous model, which is a deep learning method, and we observed that the climate variable, the El Niño sea surface temperature, and stringency index influence the trend of COVID-19 cases in South Korea. The effects in the number of COVID-19 cases were seen at least a week after there were changes in the El Niño sea surface temperature and stringency index. So this study provides initial evidence that COVID-19 cases may in fact be influenced by climatic factors. As COVID-19 transitions from being a pandemic to an endemic, it is important to determine whether COVID-19 will become seasonal, and if future outbreaks will be influenced by short or long-term climate changes. In summary, there are many factors by which climate change can impact human health, particularly with the spread and transmission of infectious diseases. Changing weather patterns can increase our risk of being infected, and changes in temperature can increase the geographic range, reproduction rates of vectors such as mosquitoes, and increase also the transmission intensity of the diseases they carry. The melting of the permafrost of the Arctic and Antarctic regions can lead to the reemergence of ancient diseases which the human population may not possess any immunity to. Increasing urbanization can also result in the shifting of wildlife habitats and increasing the risk of animal to human zoonotic infections. Increasing air population can help viruses become airborne or can increase the human host risk to have a more severe form of the disease. Global warming can also cause a selection of mutations in viruses which could result to more resistant strains. So let's all take good care of our Earth. It is the only one we have.
Thank you very much, Dr. Velasco, for that very informative talk. Now let's move on to our next speaker to give a talk on is climate change impacting animal diseases. Let us listen to Dr. Adrian Ibanez.
Good morning to everyone. Please allow me to share my screen. Good pleasant morning again to everyone. And there's been a very good discussion earlier about climate change and, of course, the One Health concept. And some of the vectors has also been discussed and how it impacts the human health. I'd like to discuss further now, this time trying to focus a bit on the animal diseases. So the question would be, is climate change impacting animal diseases? Now, climate change, while we know already that somehow it's having so much impact in the world, it's been shown also to have a significant impact on animal health. And this changes on weather patterns to the emergence and re-emergence of infectious diseases transmitted by vectors, which might also lead to disease transmission to animals. The concept on the emergence and re-emergence has also been well discussed by the previous speakers earlier. Now, I'd like to focus a bit on the two specific diseases, a group of diseases. The first would be on the vector-borne diseases, more specifically on animals. In the Philippines, we have reported trypanosomiasis, babesiosis, anaplasmosis, and even bovine leukemia virus. These are diseases that are being spread by a blood-feeding arthropods, cooler areas, especially in higher altitude areas, in livestock, tick-borne diseases, or into more temperate zones, and changes in in rainfall patterns could actually lead to expanding vector populations. If you've seen movements of and the changes of or the outbreaks of several vector wide. Now, in this particular study in China, they it's a very good model and how they showed also the One Health concept, showing that the climate change, which could cause temperature rising and heavy rain and flooding, could impact natural environment and the social environment. This in turn could have an interaction with the pathogen and the host and the vectors as well, and later on leading to the infection and transmission of diseases to the community. So we can see this is a similar concept. Apart from the mosquitoes, actually the second most prevalent arthropod vector-borne disease is the one from the tick-borne diseases. Ticks are parasites that feed on animal and human blood, and oftentimes they need to attach certain amount of time before they can actually transmit the disease. Not much has been reported yet in the country, but in one of our studies is potentially zoonotic also in humans. That's actually Anaplasma phagocytophilum, and that is among the most widespread tick-borne pathogen in Europe. So we have detected a pathogen actually in cattle, which has very close similarities with Anaplasma phagocytophilum. So in this particular study, you could see that the changing patterns also, and this one is in US, which showed that the transmission of certain infections among animals, because also of the changing climatic trends, have led to the changes in the black-legged tick life cycles. And you see here, there's one unique characteristic of ticks is that ticks can actually survive for 6 months. To think that that's very difficult to control, and they could survive also these long periods of winter. So made some significant changes on how they transmit the disease. Now in the Philippines, there's only one known tick, at least in small animals, in dogs particularly. It is the brown dog tick, or the Rhipicephalus sanguineus. In the Philippines, it has been known to be the only tick in dogs, and there are several pathogens by which it can carry. In other countries, it's known to carry the bacterium called zoonotic disease, Rocky Mountain spotted fever. It's good. It's not so good actually, but it's worth noting that Rickettsia species has already been detected. Now, let's try to look at the global scenario on how climate change is affecting animal diseases. These are reports in Russia. They have mentioned there that climate change have augmented the warming temperatures that drastically change the patterns of bird migration and prolong its contact with all migratory birds that has potentially increased the viral mixing in avian influenza virus. So this one is reported in Russia. Another report is on Europe. The range of ticks, somehow also in Lyme diseases, is actually expanding, and it's been reported probably due to changes also in temperature and humidity. Ticks actually become more active, temperature is hotter. So if the impact therefore of climate change because of these changing trends would somehow be affecting on how the ticks are reproducing. Now another vector is the mosquito. And just to introduce to some of you, there's a disease we call canine heartworm, the Drosophila imi, that it's happening in the country. And climate change may have greatly affected their presence. And as far for several reports we see in different areas of the country, this disease is prevalent, probably endemic in several areas of the country already. In Nueva Ecija, this is an example of a study showing how weather changes could impact physiologically the production of an animal. In this case, increasing temperatures and rainfalls in the Philippines due to climate changes and seasonal patterns may impact the caracals, causing excessive heat and mastitis disease. And in the flood season, they have seen also that there's an increase in the liver fluke infection. In Antique, another study here, during rainy seasons, the likelihood of livestock contracting hemosep is actually increased. So the changing weather pattern would certainly see some of the diseases increased in several areas. Now, we have done several research on tick-borne diseases, and we have summarized this in this particular review. And you can see a lot that more and more diseases, tick-borne diseases, are actually detected in the country. And this might be due also to the changing weather patterns that we observe. In small animals, in dogs particularly, we have reported now more and more diseases also are being detected. We have canine ehrlichiosis, canine babesiosis, anaplasmosis, hepatozoonoses, and canine hemoplasmosis, among others. So this is an example of what we detected before in the country as we try to do more and more surveillance, as we expect that the climate is actually become hotter, then more of the diseases might also be detected. Now, climate change has a significant impact on the incidence, distribution, and severity of animal diseases. And the effects of climate change on animal diseases are complex and multifaceted, and are most likely caused by the changes in temperature, humidity, precipitation, and the range of vectors and hosts that carry and spread diseases. Overall, it is important to recognize the interconnectedness of human, animal, and environmental health to take collective action to address this critical issue in climate change. So thank you very much, everyone. I hope you learned something, and good morning.
Thank you very much, Dr. Ibanez, for that very informative talk. Of course, we've learned a lot from your talk as well, discussing primarily on tick-borne diseases, and also for including your local studies in the presentation. Now, for our last talk this morning, we would like to call on Dr. Rachel Gay V. Pallier to deliver her talk on climate change and the emergence of zoonotic diseases. Dr. Pallier.
Thank you, academician Wendell Rivera, for the kind introduction and for inviting me in this session. Allow me to share screen. Okay. So I will be discussing about climate change and the emergence of zoonosis. So as we seek to build back better after COVID-19, we need to fully understand the transmission of zoonosis or zoonotic diseases and the threats they pose to human health and how to minimize the risk of further devastating outbreaks, including the impacts of climate change. Okay. First, let me define the term zoonosis. The term zoonosis is very plainly defined by the WHO as any infection that is naturally transmissible from vertebrate animals to humans. The infection is maintained in an animal population or as reservoir, and therefore a continuous source of human infection. This encompasses infections that are acquired by humans through direct contact with animals, or as well as infections transmitted through indirect exposure routes, such as vector-borne or environmental and food supply or food system pathogens. Okay. So did you know that around 60% of all infectious diseases in humans are zoonotic? And 75% of all emerging infectious diseases are also zoonotic in nature. In other words, many infectious diseases come to us via animals, and that includes the COVID-19. So of at least 181 diseases known to be zoonotic, 63% have been reported in the Philippines. So we have to watch out. The heat map here shows the global spatial patterns of estimated risk of zoonotic emerging infectious diseases events. So this is based on broad set of predictors like distribution of tropical forested regions, human population density, mammal species richness, agricultural land use, and others. So we see here that Philippines is at high risk of zoonotic emerging infectious diseases. Okay? It's in yellow. That means it's included as high risk of zoonosis. So why Philippines considered as high risk for zoonosis? We know that Philippines is one of the biodiversity-rich country. We are endowed with natural resources in rainforests and coastal areas. We are rich in flora and fauna. And therefore, we have abundant potential animal reservoir hosts, which include wildlife animals. Okay. Apart from that, the Philippines is also of course, tropical country, and we are archipelagic. Since archipelagic, there are several islands which are not accessible to basic services, such as health services. And as such, tropical diseases are common. Philippines is also a disaster-prone country. We are visited by typhoons, several typhoons in a year. We are also earthquake-prone, because we are located in the Ring of Fire. So these are challenges and contribute to the impact of climate change. So this will also include challenges of the unstable social political issues in the country. Okay. So let me share with you some of the types of zoonotic diseases. One is emerging zoonotic disease. This has already been touched by some of our speakers a while ago. These emerging zoonotic diseases are those that newly appear in human population or have existed previously and now rapidly increasing in incidence or geographical range. They are very common, but we are not aware of this. Unfortunately, these diseases are often not highly lethal. They are just accidental, or what we call spurious, and most do not spread widely. In humans, we can just excrete them through our feces. If they are accidentally ingested, we can just simply excrete them through the feces. And most do not spread widely. But some emerging diseases have enormous impacts. For example, Ebola, the Zika virus, of course, HIV, and now the COVID-19. These are well-known examples of emerging zoonosis, particularly harmful to human health and the economy. Okay. Another is the epidemic zoonosis, which typically occur intermittently and are, mostly domestic in origin. So examples are anthrax, leishmaniasis, Rift Valley fever, and these usually are often triggered by events such as climate variability, flooding, and other extreme weather, including famines. So the overall health burden of epidemic zoonosis is much less than that of the neglected zoonosis. However, because of shocks to food production and other systems, they can significantly reduce the resilience of affected, impoverished, and marginalized communities. In the Philippines, we have leptospirosis. We have also the foodborne trematodosis. These are examples in the Philippines of epidemic zoonosis. The last one is the neglected zoonotic diseases, which are mostly domestic in origin and continuously present to a greater or lesser degree in certain populations or communities. But these diseases affect mostly poor populations and are commonly neglected in terms of funding by the national or international agencies, as well as by the national governments. So it's likely that the poor detection and surveillance of these diseases diminish their recognition and thus less prioritization by researchers and policymakers. That's why the United Nations, through the WHO, is very proactive on the elimination of NTDs, or what we call the neglected tropical diseases. So this is one of the research or the Sustainable Development Goal agenda, that is reduction of the NTD or neglected tropical diseases. So in the Philippines, I'd like to emphasize the schistosomiasis and the soil-transmitted helminths as one of the NTD in the Philippines. Worldwide, there are 1.5 million people affected by schistosomiasis and soil-transmitted helminths. Siguro you are familiar with the ascaris, no? But this is not just the ascaris. There are several parasitic helminths that are considered neglected and are prevalent in agricultural communities. In the Philippines alone, 30 million Filipino children are infected with schistosomiasis and soil-transmitted helminths. So can you imagine 1/4 of the population? This is just children, adults not yet included. 1/4 of the population infected and suffering from these NTDs, the schistosomiasis and the soil-transmitted helminths. So in our previous recently concluded project with the University of Surrey, we reported the co-infection of intestinal helminths between humans and animals. That means that the parasites that we see in animals are now in humans, and also there are also parasites in animals that should only be seen in humans. So there is already co-infection, or what we call cross-transmission. So the schistosomiasis and soil-transmitted helminths are examples of co-infection of intestinal helminths between humans and animals. And therefore, this is a concern for zoonotic emergence of zoonotic transmission. So there are several factors that contribute to the increased zoonosis emergence. I will not discuss this in detail anymore because this has already been shared a while ago by our speakers. Okay. But indeed, the impact of climate change is alarming. Now, some studies mention that the rate of future zoonotic disease emergence or re-emergence will be closely linked to environmental changes and climate change. Okay. And the world is already witnessing the consequences of human-caused climate change, including hotter temperatures, rising sea levels, and studies show the link between climate change and the increasing threat of zoonotic emergence. Let me give some examples, like the impact of climate change on zoonosis, and let's classify them accordingly. First, on vector-borne zoonosis. This has already been shared a while ago. These are vector-borne and zoonotic diseases transmitted by arthropods, could be mosquitoes, ticks, bugs, and sandflies. And challenges for tropical countries like the Philippines is this arthropods. For example, mosquitoes. As temperature rises, there's increased spatial distribution, because of increase, there's a shift in spatial distribution, increase in vector survival and reproduction rate, and increased precipitation also will generate additional breeding sites for vectors. Okay. Now let me share with you the zoonotic malaria. We are familiar with the human malaria caused by Plasmodium falciparum and Vivax and the two others. But in Malaysia, the #1 cause of malaria is actually not the human malaria, but it's the zoonotic malaria caused by Plasmodium knowlesi. 90% of malaria in Malaysia is actually zoonotic, coming from monkeys. Now, in the Philippines, we have done some research in Palawan, and we have found out that this Plasmodium knowlesi, which is also zoonotic, is also present in the country. We have already reported this in our animals, sa mga long-tailed macaques natin, but we don't have surveillance yet in humans. And this is something that we have to consider in our surveillance. So we do not, Philippines is now at the pre-elimination stage in terms of malaria, but watch out for the zoonotic malaria because we have already recorded them in long-tailed macaques in some regions in the Philippines. Okay. So these are some vector-borne zoonoses, which has been shared a while ago. Okay, now how about waterborne zoonosis? Of course, these are spread to humans mainly by via drinking or food processing or recreational waters. But included here is also the schistosomiasis because of the snail intermediate host that is aquatic in nature. So the increased precipitation, of course, will lead to increased runoff. Most of the pathogens, most of the pathogens are fecal-borne, coming from animals, and therefore runoff, agricultural runoff, forest runoff, could lead to increased loading of these pathogens to our water ecosystems. And of course, the rising temperature of water bodies would also lead to increased reproduction cycles of pathogens, increased metabolic rate, and therefore increased potential transmission. So our study in Caraga region, and let me emphasize on the schistosomiasis because this is one of the neglected tropical zoonotic diseases. Our study in Caraga region showed that schistosomiasis imposes a large adverse economic burden, causing about 6.6 loss of agricultural production and a loss that increases 32% for households in high-intensity disease clusters. In fact, our research study showed that there is more than 50% of prevalence in endemic communities using molecular techniques. So using the microscopy, there's 5 to 10%, but when you do molecular analysis, it gets high as 60% in endemic communities. And this is very alarming. And schistosomiasis has a wide range of hosts, of animal hosts. It can infect not only buffaloes. We reported buffaloes, yung mga kalabaw, as the most significant host, but in our study, we found out that rats, pigs, cats, dogs, potentially all mammals in the environment are reservoir host of this Schistosoma japonicum. And among children, of course, this has implication. It could lead to stunted growth, it could lead to poor cognitive learning, it could lead to serious diseases, including what we call the cerebral schistosomiasis. What is very alarming, we know that in the Philippines, most typhoon tracks have always been in the northern portion. But due to climate change, new paths have emerged in Mindanao, so which is a known endemic area for schistosomiasis. So with increasing heavy rainfall and flooding, many people in these areas would be at risk of being infected with the disease because of the infective stage, larval infective stage that is waterborne in rice fields, irrigations, ponds, bodies of waters. And these are endemic in many agricultural areas in the Philippines. So these are some examples, other examples of waterborne zoonosis. We have cryptosporidiasis. These are emerging waterborne diseases, giardiasis, cryptosporidiasis, and the animal reservoir are farm animals, livestock, companion animals, and many others. The other one is foodborne disease, of course, primarily by food contaminated with pathogens. Examples are salmonellosis or amoebiasis. And of course, again, runoffs could lead to contamination of crops by animal feces. And also the increase in temperature of bodies of water could also lead to high reproduction cycles of these pathogens, leading to higher transmission. So basically, the changes in air and water temperatures can modify the seasonal and geographic occurrence of these pathogens. Higher temperature can increase the number of pathogens that are already present on produce and even in seafoods. No? While bacteria population can increase during food storage, which can also raise food spoilage rates. Okay. And this is one of the examples that of our research results, no, on the role of environmental factors, no, leading to parasite contamination and the several dynamics of transmission leading to concerns on food safety. And we found out that during wet season, there is higher prevalence of contaminated produce. So that is related to climate change. And there is no significant difference between organic and conventional farms. So these are other examples of foodborne zoonosis, which have been mentioned a while ago already. Okay. And the last one is the rodent-borne zoonosis. The rats. The rats are primarily a reservoir host of several zoonotic diseases, including hantavirus and leptospirosis. So the as rainfall increases, the rodent food sources and or as rainfall increases, there's also an increase in rodent population because of the increased food sources. And the increased temperature could lead also to increase human-rodent interaction because rodents tend to move indoors in search of food and water. So this is just one example of our works on rodents. No? One is the Angiostrongylus cantonensis, which is a meningitis-causing parasite. And we found out that in Nueva Ecija, which is the rice granary of the Philippines, we found out that more than 50% of the rodents are infected with this Angiostrongylus cantonensis. So, okay, something that we need to consider in our studies. And there are also other important rodent-borne zoonoses like hantavirus, leptospirosis. Okay. The monkeypox is also a rodent origin. So I will not discuss this anymore. This has already been shared by our speakers a while ago. No, but again, I would like to emphasize the role of One Health. The pathogens that I've discussed originate in animals, and they are and the emergence or spillover of the diseases caused in humans is usually the result of human actions, and therefore their management should be intersectoral. Okay. And not just the One Health approach, but I would like to emphasize also the eco-health, which has been defined as a set of systemic participatory approach to address or to understand or promote health and well-being in the context of social and ecological interaction. So both the eco-health and the One Health approaches emphasize multidisciplinary collaboration for holistic intervention to attain human health goals, both on not just in human health, but also in animal and environmental health. So just to share that UPLB has a program for zoonotic diseases approved by the Board of Regents, and we are establishing a comprehensive program that provides a science-based evidence to aid in the understanding of the epidemiology of emerging zoonotic diseases. So we have the College of Veterinary Medicine spearheading this UPLB program for zoonotic diseases, but we have the other units, even the College of Human Ecology, Developmental Communication, Environmental Science, School of Environmental Science, College of Economics and Management. So almost all units in the university are involved with the understanding of this zoonosis emergence. Okay, and again, I would like to emphasize the importance not only One Health and EcoHealth, but the environmental education that should include a how human beings can manage behavior and ecosystems to live sustainably. And again, let me emphasize that we have to include it in our education, all efforts to educate the public and other audiences, including print materials, websites, media campaigns. There are also ways that environmental education is taught outside traditional classroom, like we have zoos, parks, nature centers, all have ways of teaching the public about the environment. So again, for research, we have to increase surveillance, correct diagnosis, treatment, and vaccines. These are all opportunities for research. And of course, this social equity, movement toward health equity, okay, the reduction of poverty. So it's a bit complicated. Of course, reduce emission of carbon dioxide and greenhouse gases. So climate change is a shared responsibility. So we call on all the relevant sectors to help address this threat while each one meets its own responsibility. So thank you very much and good morning to all.
Thank you very much, Dr. Pallier, for that very good talk. We have clearly understood the link between zoonosis and, of course, climate change. So we will now proceed to our open forum. We will select questions from the Q&A box on Zoom. So we'd like to request our resource speakers, our keynote speakers, to turn on their cameras so that we'll have an interactive Q&A session. Let me remind everyone once again, for those who haven't typed in their questions, please do so using our Q&A box on Zoom. And for those of us who are joining via Facebook Live, kindly use the comment section box. Okay, we also would like to request our panelists to directly ask their questions. Just raise your hand so I can recognize you. Okay, we have a number of questions in our Q&A box. Some of them were already answered by our resource speakers, but we would like to ask them once again for the benefit of those watching on Facebook. Okay. Okay. Some of the questions are directly given to a particular speaker, but we would like to open the questions to our resource speakers so they can also give their viewpoints. Okay, the first question came from Ms. Rosebella Malo. But let me rephrase the question. I think what she meant was, how severe is the effect of climate change on pathogens related to pathogens found in the aquatic environment? How is it transmitted to humans? In terms of severity, how severe they could affect humans? And what are some of the mitigation measures? Okay, so anyone from our research speakers can answer those questions. So she's asking about pathogens found in aquatic environment and its and their transmission to humans.
Wendell?
Yes, Dr. Pallier, yes.
So I touch a bit of the waterborne zoonosis, and of course, academician Rivera has a lot of works on waterborne zoonosis, and we found out that most of these pathogens in aquatic ecosystems, like for example in Region 4, we have the Laguna Bay. Most of them are animal in origin, and I mentioned that this is due to runoffs. So you have the neighboring coastal with a lot of residential areas and a lot of agricultural activities, which are sources of pathogens from animals. And my take here is, in terms of policy, we have to review our land use plans. what should be the distance of these residential and establishment areas in our lakes, in our rivers? We have to review that because most of the sources are runoff. So gaano ba siya dapat kalayo? If we have that political will, we did in Boracay, we should also do that in our freshwater ecosystems.
Wow. Thank you very much, Dr. Balier, for that very clear answer. Okay, another question. I think everyone can share their ideas on this one. Question coming from Alexa Ray at Vincula. What initiatives are currently being done to achieve One Health globally? Of course, One Health approach to our problems with climate change.
I think
Yes,
there's a lot of
Dr. C.
there's a lot of initiative that you can check. The best source, of course, in the U.S. Go to CDC website and just type in CDC One Health. You can see there's so many initiatives going on at CDC, and CDC's partners are the health departments. Unlike NIH, I work at both NIH and CDC, so the CDC traditional partners are the health department. So there are 50 states health department and some county health department or city health department. But NIH, their partners are the universities researchers. So at you can see the CDC website on One Health. The other one that you should check is WHO website on One Health, and they have a lot of initiative. They even have discussion about the recent G20 meeting about climate change, and so you can see participation also with foundations. So you can see that Hilton Foundation, the Gates Foundation, there's a lot of foundations that are also involved. So for students in the audience, I think I would suggest that you should get a public health degree, and medicine may take a long time, but if you get a bachelor's or master of public health, you can easily get a job, not only in the Philippines, but also international job, and you can contribute to all this One Health work that's going on in different parts of the world.
Okay. Thank you very much, Dr. C. Any other comments from our other resource speakers?
If I may add,
Yes,
in
Dr. Velasco.
in the Philippines, there's a Philippine Interagency for a Committee for Zoonosis. So the DOH, DA, and DNR are involved in that, and they do regular meetings. For One Health, it has been around a while, but the focus in the Philippines is it's just been recently that the interest has gone up. For other countries, there's actually a PhD in One Health, like in University of Florida, that's being offered. So this one, if students are looking towards a career in the future, I think this is a good niche to focus on and study, because we need more scientists working on One Health. Thank you.
Thank you, Dr. Velasco. Okay. Thank you so much for those points. Now let's move on to questions coming from Dr. Franco Teves. This one is directed to Dr. C, but others can also give their viewpoints. Question is, can we say that human population density plays a crucial role in the transmission of the diseases mentioned together with changes in the behavior of vectors? As part of the mitigation measures, would it be prudent to look at urban planning, just been mentioned earlier, especially in highly urbanized megacities, which seem to be receiving low priority? And would it be possible to redesign our cities to attain a sustainable carrying capacity and possibly lessen the problem or transmission rates?
I think the other speakers, like the last one, Dr. Paller, mentioned that already. I think with increasing population and increasing population movement, you can see increasing transmission of diseases. And so I think that's already, there's a basis for that. And And urban planning is very important. That only urban, but also land use, as I mentioned by the other speaker too, that it's our human activities that cause all these things to happen. So if we should be more careful about the way we use our land and our environment, because the more we abuse it, I mean, it's a bad karma to just affect us too. Look at what's happening when you invade all the areas where you have reservoir hosts. Then you can and as Dr. Poller mentioned, with schistosomiasis, it's not just because people's behavior that they go to work and be exposed to the water containing the cercaria, but it's the animal host that's still infected that is also spreading the infection. So if you only treat the humans without treating the animals, and it's just the cycles keep on going on in the environment. So I think the One Health approach is very important, but I liked her approach about the eco health. In other words, you should look at sustainability, not just one shot, because you need to make sure people participate. I think the medical model doesn't work anymore, where the physician is the center of activity or the scientist is the center of activity. What we're proposing is actually partnership between physician and scientists and community members, equal partners. That the community-based participatory approach, which is CVPR, where they're equal partner in all of these activities, so that they're not just a passive recipient of activity. If they're involved in the beginning of the intervention, all the way to the dissemination, then they will be using those, making sure it's sustainable. So we've proven this in our CVPR research, that initially, once you involve them from the planning to the intervention, or the end, when you're disseminating the result of the research, it becomes community-led. They're the one leading in disseminating the research to the community. So that's very important, important point to remember.
Yeah, thank you, Dr. C.
I just wanted to add one comment to that.
Yes, Dr. Bernard.
About urban planning. I think it's definitely important to reconsider how cities are built. There are studies that show that cities, when you compare them to rural areas, are 10 to 15 degrees Celsius warmer. And so, yeah, that's going to create a lot of problems for people living in the cities. So thinking about how we design them is absolutely important.
Thank you. Thank you very much for those clear answers. Now let's move to the next question, this time by Leila Ombat, and anyone can answer this question. Given the situation that the budget is very limited to address issues on health, as an expert, what is your first or top priority or action to help decrease, eliminate the disease burden, for example, in the Philippine setting? So how do we answer that? What is your top priority?
Yeah, maybe I'll take the
Okay,
first
Dr.
one.
Ibanez.
Well, limited. Yeah, thank you very much. With limited budget, we hope to continue the surveillance of the different, in terms of the animal diseases that we are observing in the country, and hopefully, because information is very powerful, we continue to educate. And when people are educated, then we could do so much on how we could really prevent the spread of the disease. So it's something in the limited budget that we have. That's something I think that I would like to prioritize, though. Thank you.
Yeah. Thank you, Dr. Ibanez. How about the others?
Reduction of poverty, social equity.
Mm-hmm. Right. Good. Thank you. Yes, Dr. Maala. You are on mute, Academician Maala.
Okay, congratulations to Dr. Paler and Ibanez for a very informative talk on effect of climate change on the emergence of zoonotic diseases, especially. I noticed, however, in their talks that medyo deficient on what to do to mitigate the impact of climate change on zoonotic diseases emergence. So mostly mentioned were diseases that zoonotic diseases, especially parasitic in nature, that will emerge in case of climate change. But as I've mentioned, I think there's deficiency on mitigating steps that we could do to lessen the impact of these zoonotic diseases. Thank you.
Thank you very much, Academician Maala. So can we get the comments of Dr. Palier and also Dr. Ibanez? Okay, Dr. Palier first.
Okay. So in the interest of time, we're not able to explain in detail what are the mitigation risks. But I mentioned a bit about the increase in research surveillance, because in the Philippines, we are lacking on data of these potential zoonotic agents. Probably they are common in our agricultural communities, but we do not have surveillance. Number two is, of course, treatments and development of vaccines, but these are all research-based. And then, as I always mention, we have to incorporate the eco-health, the environmental education, which is also mentioned by Dr. Velasco, that we really need to educate our public in any platform, in any in all levels, from the children to adults and even senior citizens. So we have to be proactive in terms of awareness campaign. And of course, it should be a interagency, multidisciplinary. So from individual to family to community to national level. So it should be an integrative approach. It's easier said than done, but I'm happy that in the Philippines we already have organizations. We have the PhilOHUN, the Philippine One Health Network. We have in UPLB, we are starting with the Philippine Zoonotic Disease Program. And in the entire country, we already have collaborative researches and activities and awareness on webinars. And I would like to see sana sa ating in DepEd, the incorporation of this One Health and Eco Health approach.
Thank you, Dr. Palier. Any additional points from Dr. Ibanez?
Yeah, thank you very much, Dr. Palier. I think that's an additional, though, it's a very good insight from Dr. Palier, is having the involvement also of the local government units. So while we do have limited funding on this surveillance, but if it's also being made a priority by the LGUs, then certainly they could also do some funding. We do have some collaborations now, and it is we have involved the LGU. So I think it's pretty much very good work having research and extension as part also of our academic work, and hopefully since there are many researchers and having the local government involved in even in terms of information education campaign would be a very strong initiative to help out and to let people understand what can be done at the community level, at the household level, to prevent the spread of the different diseases.
I want to also add that the CDC recently established an office in Manila. So the Center for Disease Control and Prevention in Atlanta, for the first time, they established a CDC office in Manila. And this is in response to increasing HIV/AIDS in the Philippines. We have the highest and the fastest increase of HIV in Asia. So CDC is so concerned about this that they established an office there. And fortunately, the director of the office is one of my former students, and he's a Filipino born in South Carolina. His mother is a doctor. His father, I think, was working in the Navy, and so he cannot speak Tagalog, but his parents are both Filipino, and so luckily he started working with me on HIV/AIDS when he graduated in South Carolina, and worked with me when we were working at CDC together, and now he worked at the global level already. And then from Vietnam, he was assigned to work in South Africa, and then from South Africa, he volunteered and now assigned to Manila. So he's the first director of the CDC office in Manila. And my understanding is that that office is not just working on HIV/AIDS. Since he's there with some staff, I think some of the staff are from the U.S., but some staff are local because there's a partnership with the Department of Health in Manila. So if there are some collaboration that researchers or practitioners in Manila are interested in, or it's zoonotic disease or other type of research that they're interested in, they could request the CDC office in Manila, because they can be the conduit from Manila, Philippines, and the U.S. So his name is Romel Lacson. The parents are from Cavite, but if people interested, I can share his email, and you can contact him to see if there's interest to look at other diseases aside from HIV/AIDS. He may not be an expert in zoonosis or other type of diseases, but he could refer the request to other people in the headquarters in Atlanta. So feel free to email me if you have interest in this area.
Thank you so much, Dr. C. Okay, we have another question, this time from Dr. Lydia Leonardo. She's asking, the current pandemic has severely burdened the environment in terms of the trash generated from all the PPEs. Is it possible to strike a balance between ensuring human health and maintaining environmental health as well? Would like to answer this question.
I'll take a stab at it. There's some data that shows that reusable PPE is adequate for infection prevention, but it gets to be a pretty complicated algorithm. So I'm not sure if anyone is familiar with something called a life cycle analysis. Basically, what it does is you take all of the inputs and outputs from a particular product, and you see what its environmental impact is. Everything from materials to manufacture to transport, and then waste and back into the environment. And so there have been some studies that compare reusable PPE to throwaway PPE. And because of how the things are reused, the washing, the transport, it's highly dependent on how things are reused. For example, if you are washing all of your gowns in-house in the hospital that you're using them in, then that's much more environmentally friendly. But if you have to ship it, 50 kilometers to a washing facility and then ship it back, then you're burning all this fossil fuels with the trucks and et cetera. So I think there are pathways and mechanisms to be more environmentally friendly, but unfortunately it's not always as black and white or as simple as you think it should be. If you reuse something, you think, this is going to be better for the environment, but sometimes it doesn't end up turning out that way based on how systems are set up. So it's a good question. I wish there was a simpler answer.
Thank you very much, Dr. Burnham. I think that's clear. Okay, another question, this time from Christy Ango. What career paths can can the speakers recommend, aside from those occupations related to public health or medicine? Can students pursue in order to contribute to helping the masses in information dissemination of climate change and its detrimental effects to humans and animals, among others? Any other career paths that you can suggest?
If you look at the emergent factors that I discussed earlier, you can see that human behavior is very important. And so a degree in psychology or degree in communication are important because, as I said earlier, it's ideal if you have medical degree or public health degree because you know all the sciences. But if you partner with people that can communicate better and also who knows people's behavior and know how to change them, that might be helpful. So because medicine is a very long career, but so you might want to try communication, psychology, or even business, because then marketing is very important. How you market all those different campaigns or ideas, the messages are it's very important as well as a messenger. So some of us are trained as a scientist. It's so hard for us to really explain it to down to the. You have to explain to a level that the person on the street can understand your message. So I think all those degrees are equally important. If you partner with somebody with medical and public health degree, then you'll be able to really help in the One Health or Eco Health program.
Thank you, Dr. C. Okay. So let me go to those questions which have been answered already by our speakers on Zoom, written answers. But in view of those watching on Facebook, we have one good question from Dr. Franco Teves. Have there been studies to determine the mechanisms for the increase in the rates of antibiotic resistance at higher temperatures? Does effect of high temperature on host immune system and other host factors such as the release of heat shock proteins or the like also play a role in antibiotic resistance? Well, this question was addressed to Dr. Jason.
Sure. So the main factors that have been identified so far are related to increased rates of bacterial growth and increased rates of horizontal gene transfer of antibiotic resistance genes and cassettes. But, you know, the interactions are complex, as everyone has said. You know, we're all in this together, which means everything influences everything else. And I would definitely not be surprised if there are other mechanisms, including host-related ones, that are identified in the future as contributing to these antibiotic-resistant infections and their severity.
Thank you. Okay, question this time directed to Dr. Velasco. Could you give examples of ancient diseases that can re-emerge with the melting of the glaciers? Are there actions being made to deal with this possibility?
Okay. So like the glaciers, like in the Arctic or Antarctic, those are really ideal conditions to really preserve the viruses. Much like, deep freezers, -80 freezers, which you use to preserve viruses. And there have been cases actually in publications where they were able to isolate viruses from tissues, from preserved tissues that were found in the glaciers which melted. And there were publications also of isolating the Spanish flu as well as live smallpox virus from humans who were infected and preserved in those glaciers which melted. So there's really a distinct possibility that we'll be exposed to a virus which have been they call it a zombie virus, and we don't have any immune response or immunity to it.
Thank you, Dr. Velasco. Another interesting question, this time coming from Ms. Nieves Capili. Are there biological controls that have been developed to mitigate increasing population of zoonotic vectors like ticks, mosquitoes, sandflies? I think Dr. Velasquez can answer, probably Dr. Ibanez and Dr. Perea can also at some points.
Yeah, I'd like to add though. The vaccine study against ticks has already been a global initiative and so far has been very difficult to produce. There are a lot of candidates, there are a lot of trials, but so far nothing, as far as I know, have been very conclusive to produce the vaccine. But the initiative is ongoing to control the ticks. So hopefully the control of these vectors, as far as ticks are concerned, is mostly on preventatives that we are implementing for the small animals and also in large animals. So thank you.
Thank you, Dr. Ibanez. Dr. Palier?
For biological control, there are research undergoing on the role of Wolbachia bacteria that can somehow have an impact on the reproductive capacity of vectors like mosquitoes. So there are studies undergoing now, even in RITM, on Wolbachia research as biological control of vectors.
Thank you, Dr. Palier. Okay, thank you for those answers. Okay, now
I think for schistosomiasis, a long time ago, they tried duck to eat the Oncomelania snails in China. So I don't know if that's been tried in the Philippines or not, but in China they've tried ducks as to eat all those small snails of Oncomelania, but that's a biological control.
Yeah. Thank you, Dr. C. Okay, now let's go back to AMR, antimicrobial resistance. We have a question from Alma Lorelai de Jesus Abijero. For AMR, all factors mentioned lead to increase and spread of AMR. Is there any intervention that can slow down AMR, or can AMR be reversed to some extent? We have a written answer from Dr. Velasco. You may want to comment on this.
Okay. So as we know that there has not been a new antibiotic class that has been invented or created in the last decade or 2 decades or so. So we're really running out of antibiotics to treat this emerging bacteria that's highly drug resistant. Antibiotic stewardship is one of the ways, the judicious ways and correct way of using antibiotics that could extend the usability of our current antibiotics. In the Eastern Europe, such as Georgia, the country Georgia, they have used bacteriophages actually to kill highly resistant bacteria because bacteriophages can also evolve if they're super bugs, then the bacteriophage could also evolve into a super bacteriophage to kill those superbugs. So that research is currently being revived, and new ways to use bacteriophage to address multi-drug resistant bacteria is up and coming.
Thank you, Dr. Velasco. Yes, Dr. Burnham.
I was just going to add that that principle applies to agricultural antibiotics as well. I can't remember which pathogen it was, but there was an invasive pathogen of a type of tree, I believe in Florida, and they used, in order to try to eradicate it, more streptomycin in one spraying than I think the whole state of Florida had used for a year. So you can imagine that if you cut down on the amount of bacteria antibiotics they're using in livestock and farming, you're going to have a lot fewer opportunities for resistance development. So not that it's not important to do that for humans, but we also have to think again about the interconnectedness and making sure we're stewards in the environment with livestock and plants as well.
Thank you, Dr. Burnham. Okay, we have a question from someone from the Mindanao State University, Iligan Institute of Technology. Thank you, dear speakers. There is a heavy physical movement every day, especially with commodities involving plants, both for humans and livestock. Nonetheless, the waste generates. What could be the research priorities for One Health approach in this aspect?
I'm not totally sure if this is an answer to the question, but hopefully it'll provide a little bit of insight. I think I don't know globally, but in the U.S. we have a big food waste problem, and so in some places up to 40% of food just goes to waste. So yeah, you're wasting 40% of all that transport and energies in that way. So that's a big chunk of the expenditures of pollution and greenhouse gas emissions and such. So if we can reduce food waste, then we're becoming more efficient in the foods that we transport and use. So not to say that there are not other improvements that could be made, but if you're wasting 40%, then that's 40% extra emissions that you don't really need to be if you could just figure out how to get that food to people who need it.
Great. Thank you, Dr. Burnham. Okay, we have a question directed to Dr. Palier from Dr. Lydia Leonardo. Do you foresee not only emergence but dominance of Plasmodium knowlesi over Plasmodium falciparum and Plasmodium vivax in the future? How can this be prevented?
Yeah, one example here is the story of malaria in Malaysia. So we have, it used to be the human malaria only caused by Plasmodium falciparum, vivax, vale, and malariae. But in the past decades in Malaysia, the zoonotic malaria caused by Plasmodium knowlesi, which is innate in monkeys, but because of spillover from monkeys to humans, it is now the dominant cause of human malaria in Malaysia. So if it happened in Malaysia, it could also happen in the Philippines. So that means we have to really watch out for this zoonotic malaria in the country, because we have documented them in long-tailed macaques. In our study, we only documented in Palawan, but we have to do more surveillance in other areas in the country, especially in Mindanao and in the Visayas. So I hope I answered the question.
Thank you, Dr. Palier. We have a question for Dr. Ibanez coming from Dr. Franco Teves. In terms of impact of climate change, should we focus on vector control as part of the mitigation measures? As presented, vectors become more active at higher temperatures. We have also demonstrated it in our lab for Aedes aegypti. Females are more aggressive at higher temperatures and life cycle becomes shorter. Dr. Ibanez.
Thank you for that question, Dr. Teves. Certainly, mitigation, in terms of the mitigation initiatives, controlling the vector would, I think, much more accessible to do compared to really controlling the entire climate change as a whole. So that's I totally agree that controlling the vector would be the best. As I mentioned earlier, we have introduced the concept of giving preventatives also to livestock and to small animals, and in doing so, we are preventing also the transmission of the diseases. Thank you.
Thank you, Dr. Ibanez. Okay, another question for Dr. Ibanez, this time coming from Nadine Matondo. What countermeasures are developed to limit the geographic range of vectors due to the change in climate patterns?
Yeah, I think this is a standard protocol by our country that for any animal going in, it has to undergo some sort of testing for certain diseases of economic concerns. And we also do quarantine measures to prevent, because we're not only trying to detect the diseases, but also to control also the vectors that they might be carrying as they enter our country before they are being integrated to the common population. So just to prevent any transboundary diseases to go into our boundaries. Thank you.
Thank you so much, Dr. Ibanez. Okay, so in the interest of time, I don't think we can still discuss some of the other questions posted in our Zoom Q&A box. But before we conclude this Q&A portion, we would like to request all our research speakers, our keynote speakers, to give a few statements, take-home messages to our audience with regard to our topic, microbes and climate change in human and animal health. So maybe we can start with our keynote speakers. First, Dr. C.
I think my last slide showed that message that we're in this together and all of us have a role to play. So each one teach one. Thank you.
Thank you, Dr. C. Dr. Burnham.
I think Dr. C took what I was going to say, but we really are all in this together. And I think the other thing that I would, this is a little bit tangential, but I think there's been a lot of messaging about individual responsibility when it comes to mitigating climate change. And I think that causes a lot of climate anxiety and people like, oh, which brand do I buy? Which company is the best for the environment and all that. And, certainly individual choices make a difference in terms of carbon footprints and stuff. But I think in the larger picture, we need sort of collective action, and we need to hold people and corporations and stuff accountable, because ultimately, that's where the bulk of the carbon emissions are coming from. And so don't get overwhelmed at trying to pick which company has less, carbon footprint that you should buy your clothes from or your food from or something. You have to recognize that you're one part in a larger movement, and whatever actions that you can take as a group is going to be beneficial. So see what groups are already doing in your area and get involved.
Thank you, Dr. Burnham. Dr. Velasco.
As I said in my last slide, we should protect the Earth because it's the only one we have. We still don't have an option to go to Mars or another planet if living in Earth is not conducible anymore. So yeah, it's a united front, and we should protect each of us should protect our environment.
Yeah, thank you, Dr. Velasco. Dr. Ibanez.
Yes, I do have a similar message, but I will not copy it. But there are 2 points. First point, that all professions and fields are very critical and important in this role that we have on climate change and how we prevent diseases from actually being spread. And so we are all important in this. We're all in this together. And the second point is, we as a member of the community and society, that we have the role to play and how we would protect the environment to prevent climate change or mitigate its effects also. So God bless us all. Thank you.
Thank you so much, Dr. Ibanez. And last but not the least, Dr. Pallier.
Okay, so my message is the African proverb: if you want to go fast, go alone. If you want to go far, go together. So do not work in silos. Do not work as individuals. We can do more when we work as a group. And the other thing is, we need to emphasize on the capacity building, especially of our local governments, because they are the key players in our local communities. So as researchers, in the academe, in our related agencies, WHO, DOH, DENR, we have to help each other, and as I've mentioned, work together to train our local governments, all units, to reach our goal for social health and One Health. Thank you.
Thank you very much, Dr. Palier. Okay, thank you very much to all of our speakers. Once again, let's all give them a warm, big virtual applause, okay, for their very good presentations and, of course, their answers to your questions. So thank you, Dr. C, Dr. Burnham, Dr. Velasco, Dr. Ibanez, and Dr. Palier, and, of course, to our participants for an interactive Q&A session. Okay, so I think the cameras of all our speakers are still on. So let's have a group photo. We'd like to request our NAST secretariat to take our photo. Please give us a cue.
I'll count to 3. 1, 2, 3. One more. 1, 2, 3. Thank you.
Thank you very much. Thank you. Okay, so let's now have a synthesis of our discussion. Now to deliver this synthesis, let me call on Dr. Leslie Michelle M. Dalmasio, Outstanding Young Scientist of 2012, and currently a professor at the College of Medicine, University of the Philippines, Manila. Dr. Dalmasio, the screen is now yours.
Good morning, everyone. Let me just ask for a permission to share screen. Thank you. So it has been a very enriching morning, I think, with the presentation of our very good resource persons for this focus group discussion on microbes and climate change, focusing on human and animal health. So the discussions evolved on confronting emerging infectious diseases and climate change from local to global, climate change and antibiotic resistance, dynamics and impact of the climate crisis on infectious disease threats, climate change impact on animal diseases, and climate change and the emergence of zoonotic diseases. So we had a good keynote talk by Dr. C on promoting One Health to confront emerging and the emergence or reemergence of infectious diseases and climate change. So Dr. C mentioned that in the last century, there has been many emerging as well as re-emerging diseases. And these emerging as well as re-emerging diseases do not only include bacterial or viral diseases, but also neglected tropical diseases. And he told us that the WHO has a program for the reduction of these NTDs by 2030. So I particularly mentioned NTDs because this was tackled by the talk of Dr. Palier. So Dr. C introduced to us the convergence model of human and microbe interactions leading to disease transmission, wherein climate change is just one of the factors contributing to disease emergence, because the other factors contributing to emergence would, of course, include biological, economic, even political factors, and of course, there would be the public health measures and as has been discussed thoroughly this morning, climate and weather. So it has been observed globally that climate change effects on humans range from respiratory illness up to mental health. And as to the climate change effects on the pathogen itself, it's basically on pathogen ecology, focusing or impacting the life cycle or development of the pathogen, which was also discussed thoroughly by our other speakers, as well as the changes in the reservoir or how the pathogen now impacts the host. Now, intervention strategies to mitigate climate change effects on infectious diseases would of course need a transdisciplinary approach. So even at the start or at the keynote talk of Dr. C, he has already mentioned the need for a transdisciplinary approach that would of course involve the health sector, and there should be an infusion of funding for the efforts. There should also be decision support or decision support analytics and enhanced use of environmental information, and of course, capacity building. Now, of course, climate change impacts directly the pathogens, and the increase in transmission of disease is also exacerbated by antibiotic resistance of the pathogens. So Dr. Burnham told us that basically it's because heat is a catalyst for bacterial gene transfer, and heat accelerates bacterial growth. And we have seen this in many infections, including infections caused by E. coli, Klebsiella, Staphylococcus, and even Acinetobacter. So it's the warming climate that we have, or more extreme weather events that we have that would displace people. And when there is displacement of people, when people would have to go to shelters, to temporary shelters, of course, the crowding in the shelters would now cause or increase the risk for disease transmission. And also due to the warming climate, there would be an effect on plants, such that plants would require more fertilizers. And it has been shown that the use of nitrogen fertilizers can also increase antibiotic resistance. And not only increase antibiotic resistance, but of course, nitrogen fertilizers can also contribute to pollution. And there is also what you call pollution-induced antibiotic resistance that is caused by not only nitrogen fertilizers, but also heavy metals and microplastics. It's very interesting to learn today that microplastics can induce gene transfer in microorganisms, and this gene transfer would, of course, promote antibiotic resistance or the spread of antibiotic resistance. Now, another climate change related factor that induces antibiotic resistance is drought. Because when there is water scarcity, it has an impact on sanitation. It can reduce sanitation, and it could also lead to an increase in waterborne infections. And also when there is drought, there could be an issue on food security. Less food could lead to poor nutrition to a reduction in immunity or immune responses in humans, and thus could also make humans more susceptible to infections. Okay. Now, agricultural antibiotic use could also increase antibiotic resistance, and due to agricultural antibiotic use, the runoffs, for example, from antibiotics use in agriculture could cause the spread of antibiotic resistance. Now, Dr. Velasco informed us about the dynamics and the impact of climate change on infectious disease threats. Now, we were informed that the Philippines the Philippine risk to climate hazards is high, and climate change can result to like more resistant strains of pathogens, and this has been seen in dengue. And climate change can also increase spread of infectious disease, and we have seen this in COVID-19. There were studies presented by Dr. Velasco on providing evidence on the seasonality of outbreaks for dengue and COVID-19. But aside from the seasonality of outbreaks brought about by climate change could also cause a shift in wildlife habitats, and of course air pollution air pollution could facilitate pathogens becoming airborne and thus becoming more transmissible. Now, Dr. Velasco has also informed us that disease outbreaks can impact GDP. And in fact, for a developing country like the Philippines, a decrease in GDP would have or this economic impact would impact other sectors of the country. And as regards disease spread in a developing country such as the Philippines or in the ASEAN region, disease spread is contributed by an increase in the population and of course urbanization and mobility in terms of travel. So in terms of urbanization, urban design is very important in mitigating infectious disease spread brought about by climate change. And the importance of urban design has also been emphasized in our open forum. Now, in the talk of Dr. Adrian Ibanez, he focused on vector-borne diseases, and he told us about the vector-borne diseases that could occur in our country as well as in other countries. And these vector-borne diseases are those brought about or those transmitted by mosquitoes, snails, and ticks. And he has mentioned that climate change has, for example, also impacted the tick life cycle, leading to a difficulty in the control of ticks and thus the spread of infectious disease caused by ticks. Their studies in Nueva Ecija and Antique have shown that changing weather patterns actually impact animal infectious disease. And he has emphasized the importance of surveillance because climate change impacts incidence, distribution, and severity of animal diseases. And in the talk of Dr. Pallier, she has mentioned that the Philippines is a high-risk region for zoonosis because we have a rich wildlife diversity. The Philippines is archipelagic and the Philippines is also disaster prone. And it's interesting to note that 60% of infectious diseases are zoonotic and 75% of emerging diseases are also zoonotic. And there are different types of zoonosis, but the Philippine zoonosis that she focused on include soil-transmitted helminths, schistosomiasis, and malaria. So it's very interesting to note that there is co-infection of intestinal helminths in humans and animals. So you really see in this study of Dr. Pallier and her colleagues on schistosomiasis and soil-transmitted helminths that their findings on the co-infection is actually alarming. So there should be a continuous surveillance for this soil-transmitted helminths and schistosomiasis, but she has also called our attention on the emergence of zoonotic malaria, the Plasmodium knowlesi, that we should also perhaps start surveillance on this Plasmodium species. Now, she has mentioned that increase in temperature and precipitation could affect breeding sites of vectors and also agricultural runoffs could be affected by the increase in temperature and precipitation, as well as in the increase in reproduction cycles of pathogens. And this would, of course, have an impact on the transmission of the pathogens. So the take-home message of Dr. Pallier is that the management and prevention of zoonotic diseases need intersectoral efforts. So it may be through the One Health approach as well as through eco-health approach. Now, these intersectoral efforts on the management and prevention of zoonotic disease has again been emphasized in our open forum. So the final takeaways for the FGD this morning are the following. The physician is not anymore the center of management and prevention of infectious diseases. We have to protect the earth. We have to protect our environment because the environment impacts our health. And the approach is really a community-based, participatory approach. All of us has a role to play. So let's be more cognizant of this need and let us all do our part. Thank you very much and good morning.
Thank you very much, Dr. Leslie Dalmasio, for that excellent synthesis of all the presentations today. Now, to formally close this event, let us all welcome Academician Asuncion K. Raimundo, member of the NAST Biological Sciences Division, NAST Focal Person on Microbiology Education, and the chair of the organizing committee of this three-part series of FGD on microbes and climate change. Academician Raimundo.
Good morning. This is the last of the three series of focus group discussions on microbes and climate change. Allow me to wrap up all these three sessions. If you have attended all of them, I hope that by now you realize the power of the microbes and the important role in climate change. Microbes produce and consume the three dominant greenhouse gases that are responsible for 98% of the increased warming. Fortunately, microbes also consume these three gases and do so when their growth conditions favor the use of these gases as resources. We should then try to understand and implement practices that mitigate microbial activities to decelerate the production of these gases, such as sustainable land management practices, or utilize microbes to repurpose waste carbon or nitrogen into useful or stable products. Microbes with pathogenic potential respond to climate change by having their ranges extended via vectors such as insect vectors, flooding, or severe storms, and the host, human, animal, or plant, affected by climate change may become more vulnerable. We just heard today about the effects on microbes on human and animal health. The foremost issue is the multi-drug resistant pathogens, which can reach our drinking water, food, crop irrigation, or swimming beaches. I will no longer belabor the other issues raised today, as Dr. Dalmasio gave a good synthesis. The question that has to be raised now is, what do we do with all the knowledge, info shared with us in this three series of FGDs? Will the researchers, modelers, policymakers on climate change consider the microbes in their proposals and various activities? Will the teachers present in these FGDs emphasize more and incorporate in their lectures on discussions about microbes' role when they discuss climate change? How about us microbiologists? Dr. TG, during the first FGD, concluded that microbiologists should be challenged to understand and manage these microbial processes to minimize climate change. Previous speakers also emphasized the need to integrate a systems approach and multidisciplinary approach, addressing the issues brought about by food security and climate change, and the tools that can be employed to understand and address these issues. There were a lot of recommendations that were proposed during these FGDs. Can we and how will we implement them? What can NAST and the Microbiology Consortium in the Philippines do about this? All these questions are actually for all of us to think about, and perhaps in small ways, we can do our share in resolving the various issues brought out in this series of FGDs. On behalf of the National Academy of Science and Technology and the Microbiology Consortium of the Philippines, I wish to thank for today's FGDs our plenary speakers, Dr. C and Dr. Burnham, resource persons, Dr. Velasco, Dr. Ibanez, Dr. Palier, Dr. Leslie Dalmasio for her synthesis, Dr. Villegas for serving as rapporteur, my co-members of the organizing committee of all three FGDs, Academician Windel Rivera, who also led and moderated the FGD today, Academician Virginia Cuevas, and corresponding member Francis de los Reyes III, the staff of NAST Philippines, and all of you who attended this FGD and other previous FGDs. Thank you, everyone, and good morning, rather good noon.
Thank you very much, Academician Raimundo. Okay, again, would like to thank Dr. Lucille C. Villegas, Outstanding Young Scientist of 2009, also Professor at the Institute of Biological Sciences, UP Los Baños, for serving as our rapporteur for today's FGD. Kindly answer our short survey before leaving the Zoom webinar. Participants who accomplished the evaluation form are entitled to receive a certificate of attendance. Please follow NAST's official Facebook, Twitter, and Instagram accounts flashed on your screens. So on behalf of NAST Philippines, thank you all for joining us this morning. It has been my pleasure to serve as your host for this activity. Once again, thank you and see you in the next discussions.
Thank you.
Thank you, everyone.
Welcome to the Philippine Science Heritage Center's new Salin-Lahi Science Center, honoring our top Filipino scientists and their game-changing contributions to the world of science. Know more about all of them and let the Salin-Lahi Science Center be your gateway into their minds. Salin-Lahi.